SCADA stands for Supervisory Control and Data Acquisition. It is a software system employed to remotely monitor and control industrial processes. SCADA enables operators to visualize data, send commands, and receive alarms from distant equipment. SCADA operates through several key components. Firstly, field equipment such as sensors and actuators gathers data and controls equipment in the field. Secondly, remote terminal units, or RTUs, connect field devices to the SCADA system, transmitting data and receiving commands. Thirdly, a communication network transmits data from the RTU, either wired or wirelessly, to the master SCADA server. Fourthly, the master SCADA server hosts the SCADA software, which receives and processes data, generates alarms, and offers an interface for operators. Fifthly, an operator interface allows personnel to interact with the SCADA system through a graphical user interface, enabling them to monitor data, issue commands, and manage alarms. SCADA, programmable logic controllers, or PLCs, and distributed control systems, or DCS, each have distinct functions. SCADA focuses on monitoring, data acquisition, and the remote control of a wide range of equipment. A PLC controls logic-based processes and is used for automating specific tasks within a machine or a small system. A DCS is a large-scale control system utilized in complex industrial processes, delivering real-time control, monitoring, and data acquisition capabilities. SCADA systems are implemented across various industries, including power generation and distribution, water and wastewater treatment, oil and gas production and distribution, manufacturing, transportation, building automation, and healthcare. The advantages of SCADA include remote monitoring and control, real-time data visualization, alarm management, historical data storage and analysis, improved process efficiency, and cost savings through reduced downtime and labor costs. The core functionality of a SCADA system revolves around data acquisition, data communication, data presentation, and control. The data acquisition component involves gathering data from remote locations. This is achieved through various sensors and remote terminal units. Sensors measure process parameters such as temperature, pressure, flow rate, and level. Remote terminal units convert sensor signals into a digital format and transmit them to the central SCADA server. Data communication involves transmitting the acquired data from remote sites to the central SCADA server. This is done through various communication channels such as radio, telephone lines, satellite, and Ethernet. The communication infrastructure must be reliable and secure to ensure data integrity. Data presentation involves displaying the acquired data to operators in a user-friendly format. This is accomplished through graphical user interfaces, which provide real-time visualization of the process. Operators can monitor process parameters, view trends, and respond to alarms. Control involves sending control signals from the central SCADA server to remote devices to regulate the process. Operators can issue commands to start or stop equipment, adjust set points, and take corrective actions. Control signals are transmitted through the communication network to the remote terminal units, which then activate the appropriate actuators. SCADA systems offer several key features. Real-time monitoring allows operators to view process parameters in real time. This enables them to detect and respond to abnormal conditions promptly. Alarm management provides alerts when process parameters exceed predefined limits. Alarms can be visual, audible, or both. Operators can acknowledge alarms and take correct actions. Historical data logging involves storing process data for future analysis. This data can be used to identify trends, optimize process performance, and troubleshoot problems. Reporting generates reports based on historical data. Reports can be used to track process performance, identify areas for improvement, and comply with regulatory requirements. Remote control allows operators to control remote devices from a central location. This eliminates the need for manual intervention and reduces labor costs. Security protects the SCADA system from unauthorized access and cyber attacks. Security measures include firewalls, intrusion detection systems, and access controls. SCADA architecture typically consists of several layers. The field layer includes sensors, actuators, and other devices that are directly connected to the process. The remote terminal unit layer includes remote terminal units that collect data from field devices and transmit it to the central SCADA server. The communication network layer provides the communication infrastructure for transmitting data between remote terminal units and the central SCADA server. The central SCADA server layer hosts the SCADA software, which processes data, generates alarms, and provides an interface to operators. The operator interface layer includes graphical user interfaces that allow operators to monitor and control the process. SCADA systems are designed with redundancy to ensure high availability. Redundancy involves duplicating critical components, such as servers, communication links, and remote terminal units. If one component fails, the redundant component automatically takes over, minimizing downtime. SCADA systems are integrated with other enterprise systems such as manufacturing execution systems, or MES, and enterprise resource planning, or ERP, systems. This integration enables data sharing and coordination between different departments. For example, SCADA data can be used to update production schedules in the MES system or to track inventory levels in the ERP system. When selecting a SCADA system, several factors should be considered. Scalability refers to the ability of the system to handle future growth. The system should be able to accommodate additional devices and data points as the process expands. Reliability refers to the ability of the system to operate continuously without failure. The system should be designed with redundancy and should be thoroughly tested to ensure its reliability. Security refers to the ability of the system to protect against unauthorized access and cyber attacks. The system should have robust security features, such as firewalls, intrusion detection systems, and access controls. Usability refers to the ease with which operators can use the system. The graphical user interface should be intuitive and easy to navigate. Cost refers to the total cost of ownership, including the initial purchase price, installation costs, and ongoing maintenance costs. Different communication protocols are used in SCADA systems. Modbus is a serial communication protocol widely used in industrial automation. It is simple to implement and supports a variety of devices. Distributed Network Protocol 3, or DNP3, is a communication protocol specifically designed for use in SCADA systems. It offers advanced features such as secure authentication and event reporting. International Electrotechnical Commission 61850 or IEC 61850 is a communication protocol used in substation automation. It supports advanced features such as generic object-oriented substation event or GOOS, messaging and sample values or SV. OPC Unified Architecture or OCUA is a platform-independent communication protocol that enables interoperability between different systems. It offers advanced features such as security, data modeling, and discovery. SCADA systems are used in various applications. In power generation and distribution, SCADA systems are used to monitor and control power plants, substations, and transmission lines. They enable operators to remotely control equipment, monitor power flow, and respond to outages. In water and wastewater treatment, SCADA systems are used to monitor and control water levels, flow rates, and pump operations. They enable operators to remotely control equipment, monitor water quality, and respond to emergencies. In oil and gas production and distribution, SCADA systems are used to monitor and control pipelines, storage tanks, and pumping stations. They enable operators to remotely control equipment, monitor flow rates, and respond to leaks. In manufacturing, SCADA systems are used to monitor and control production lines, assembly lines, and robotic systems. They enable operators to remotely control equipment, monitor production rates, and respond to equipment failures. In transportation, SCADA systems are used to monitor and control traffic signals, toll booths, and railway systems. They enable operators to remotely control equipment, monitor traffic flow, and respond to accidents. In building automation, SCADA systems are used to monitor and control heating, ventilation, and air conditioning, or HVAC systems, lighting systems, and security systems. They enable operators to remotely control equipment, monitor energy consumption, and respond to alarms. In healthcare, SCADA systems are used to monitor and control medical equipment such as patient monitoring systems and infusion pumps. They enable clinicians to remotely monitor patients, adjust treatment parameters, and respond to emergencies. SCADA security is a critical concern. Cyber attacks can disrupt operations, compromise data, and even cause physical damage. Common security threats include malware, phishing attacks, and denial of service attacks. Security measures include firewalls, intrusion detection systems, access controls, and encryption. Regular security audits and vulnerability assessments are also essential. The future of SCADA involves several trends. Cloud-based SCADA systems are becoming increasingly popular. They offer several advantages, such as lower costs, improved scalability, and enhanced security. The Industrial Internet of Things, or IoT, is driving the adoption of smart sensors and connected devices. These devices generate vast amounts of data that can be used to improve process performance. Artificial intelligence, or AI, and machine learning, or ML, are being used to analyze SCADA data and identify patterns that can be used to optimize process control and predict equipment failures. Mobile SCADA systems are enabling operators to monitor and control processes from anywhere using smartphones and tablets. This improves response times and reduces the need for on-site personnel. SCADA systems are evolving to meet the changing needs of industry. They are becoming more scalable, reliable, secure, and user-friendly. They are also being integrated with other enterprise systems to enable data sharing and coordination between different departments. Overall, SCADA is a crucial technology for modern industrial automation. It provides the tools necessary to monitor, control, and optimize complex processes, leading to increased efficiency, reduced costs, and improved safety.